Hey, welcome everyone. Time to get started. Everyone is here. Perfect. Cool. Today we're going to talk about empowering DBT developers. So a small bit of preliminaries beforehand. Who am I? So my name is Pádraic. If you've already forgotten how to pronounce it because it doesn't look like how it's spelled, don't worry. I'm used to it. So I work for Xebia. So we're a data consultancy based in Amsterdam in the Netherlands, but with offices around the world. So as part of this work, I get to see a lot of DBT implementations. So sometimes you're in the discovery hall next door and you're asked, what's your warehouse? What's your database? We do all of them because we have many clients. So some of the things that this means is that we get to see a lot of different implementations. We get to see a lot of different problems. We get to see a lot of different solutions. So today is about sharing some of those, seeing what people do, provoking a bit of thought, and yeah, maybe there's something there for you. So quickly, the agenda. Throughout the slides, I'm going to have a lot of references and URLs. So if anyone wants the deck, there's a QR code. I'm going to show it on the last slide as well in case anyone doesn't get it. So in terms of the agenda, we're going to do the tools first. We're going to try and define the problem because how can we solve the problem if we don't agree what the problem is? We're going to look at some approaches and then we're going to do a quick summary at the end. So I see a few phones. Perfect. Let's move on. Tools and terminology. So we're on the last day of the DBT conference. Hopefully everyone understands what DBT is now. For anyone that doesn't, yes, you can read the words. The important thing here for us and for this talk, we're going to limit ourselves to the cloud version. So you can apply the same method of thinking to core, and I'm happy to discuss that afterwards because we've applied similar stuff to the core. But yeah, we're going to deal with cloud here. Cool. So one of the terminologies, one of the buzzwords, hopefully everyone has heard, is data mesh. So what the heck is data mesh? So if anyone recognizes this slide and the very small picture in the top right, so this is something from one of the engineers at ThoughtWorks a couple of years ago. There were 4 principles. You can see them here. So this is quite important for setting up our discussions and our basis, essentially our framework. So the first one is domain-driven architecture. So each team should be in charge of their own architecture. Now, what does architecture mean? Sometimes this means infrastructure, underlying Databricks cluster, access to a BigQuery data set, but also what runs on top of this. How is it orchestrated? How does my CI/CD work? So this is a rather broad term here. The second one, data as a product. Hopefully we have a few PMs in the audience that recognize this and can give a much better definition than I can. Essentially, even if you're providing data internal to your company to a different team or a colleague in your own team, treat it like an external product. Don't make breaking changes. And when you do make improvements, announce them so that people can expect those changes. The third one, the self-serve infrastructure. Each team should be able to approve, create, delete, destroy, remove, edit anything of their own infrastructure. So you shouldn't be reliant on a central data engineering team that you only talk to via Jira tickets. You should be able to do things yourself. The last one is a couple of more buzzwords. So essentially federated governance means you have all your different domains doing their own thing. They have their own architecture. They have their own product. They create their own infrastructure. At the end of the day, they do have some commonality. They do agree to a common way of exposing their products. They agree to using a common data catalog. They agree to a common way of providing access to PII data, stuff like this. So this time last year at Coalesce, who was at last year's Coalesce? Okay, a couple of people. So one of the announcements was DBT Mesh, and you've seen a lot of references to this week. So DBT Mesh is essentially applying data mesh to DBT Cloud. So you can see, I took this screenshot from the website, and you can see that they have 3 pillars, principles, whatever we want to call these. These are very similar to the 4 principles of data mesh that we just looked at. So we can say DBT Mesh, yeah, this is just data mesh for DBT. So what is the problem that we're going to talk about today now that we have a common background? So we take DBT Cloud, we take data mesh, we get DBT Mesh. We see this at our clients. How does this work in practice? Because a lot of the announcements we see, a lot of the features are like, hey, look at this new fancy feature. Isn't this amazing? Now you can do this. But we're in teams, and we have Jira tickets, and we have deadlines, and some of us get Slack messages at 4 a.m. in the morning that stuff is breaking. So how does this actually work? There are a couple of approaches in terms of the orchestration aspects. So again, the title is self-serve jobs. So let's have a look at these. How are we going to approach it first off? In DBT Cloud, you have an API. So this allows you to do automations on all aspects of your DBT Cloud account. On top of this, you also have the Terraform provider. So if people were in Benoit's talk yesterday, he maintains the Terraform provider. He's in the Discovery Hall if anyone wants to chat to him. At scale, especially in a data mesh or a DBT mesh, automating your projects, automating your jobs, automating your access is super important. Doing this via code so that it's repeatable at scale, yeah, you're going to save yourself a lot of time here instead of clicking things together. The nice thing is, with both the API and the Terraform provider, they also give us options regarding our jobs. So we're going to look at two of these. So the first one is Terraform. So like I mentioned, at scale, if you have a DBT mesh and DBT Cloud, you really should be looking into using Terraform for your projects. This allows you to scale very quickly. One of the other things you can do in DBT Cloud, hopefully the text is big enough, you can define your jobs. So I have a daily job that runs, it builds everything. I'm going to put that in code. I now want an hourly job that builds a subset. I'm just going to add that to my repo as well. And then Terraform will create all of this. So everything is code, there's a PR trail, there's approvals, I can link it to my Jira tickets. Very nice way of working. What happens when you make a change? So on the left, you can see that I've changed the schedule from running every day to running only on weekdays. And then using an example from GitHub, I get a change request, I can see this is changing to that, someone will come and approve it, I click merge, it gets automatically deployed. Now this is nice, and let's look at some of the advantages and disadvantages. So the top one, we now have self-serve cloud infrastructure. And remember back to the 4 principles of data mesh, this is pretty close to the one of them. In fact, it's close to 2 of them. We now have self-serve ability, and we have infrastructure that we can manage ourselves, not reliant on a different team. We also have a nice one where our jobs are now treated as infrastructure. So sometimes we see clients, they will have automated the deployment of their DBT Cloud projects, but their jobs are still clicked together. They still have that one person, you know, he's an admin, he can do it. Oh, she's a team lead, she's the only one that has access to change this. That's not very repeatable, especially once you branch out to multiple different projects. There are still some disadvantages with this. So for anyone that's used Terraform in their daily job, Terraform does a lot of different things. In fact, it's an entirely separate repo to your DBT projects. And sometimes people make changes to their Terraform and they will deploy them to, for example, their testing environments. They're not ready to use to production yet. So you may want to make a change to your DBT Cloud job, but someone else wants to spin up a new small cluster in their Snowflake account, and they're not ready to move to production yet. You have to wait for them. That's not very self-serve. You're now dependent on someone else. The second one here is the environments and the release strategies. Some places have code freezes. For example, over a Christmas period, over a holiday period, if you're a company that has a peak season somewhere. Maybe you have a code freeze to reduce the chances of outages in production. Terraform is very much infrastructure changes. Something going wrong can have big consequences. So now you just want to change a new job, edit an existing job, you're now stuck because you have to go around this, and maybe you need a VP of engineering to approve this for you. So Terraform, awesome for creating your cloud project, not so great for actually defining your jobs. So let's look at another approach. The API is something that Terraform is built on top of. What if we built our own thing on top of the API? Because then we have maximum control. We can make do the way we want it to be done. So one thing we have here, and I have a link at the bottom, we have a DBT Cloud Jobs Python package, which I've created and which we've used at different clients. In our repo, and this is important, this is our DBT repo, we have a YAML file, and it looks like the one on the right here for one job. The YAML file defines our job, and it's in YAML, which we're all a little bit too familiar with from working with DBT. We can run DBT Cloud Jobs on our command line in our CI/CD, so that when we edit this file and when we merge it to our main branch, the changes get automatically applied. So this is pretty nice. So let's do the same thing as the last time. Let's look at some of the pros and cons. So we have the same pros as the last time. We now have self-serve jobs. We now have jobs as code. In fact, the first one is even nicer because now it's in the same repo as our DBT project. So same repo, same lifecycle. And I think this is a really big one, same environments. Let's actually run through what this means. So if you think of a scenario where you're making a big refactor of your DBT project, for example, you're adding an entirely new finance domain, maybe you're splitting your marketing into internal and external. Normally, you would have to make that change in your DBT repo, roll it out, merge it to main, then jump over to, for example, your Terraform repo, change your jobs in there. You now have two different repos, two different release cycles. You have a mismatch period in between where you have jobs defined that reflect models that maybe don't exist anymore. Now we can change our models and our project architecture at the same time as our jobs. So this is much smoother. You get one merge, one PR makes all the changes. We still have some downsides. So this isn't stateful. And what does this mean? So for people that are familiar with Terraform, Terraform is stateful. So this means that if I want to remove a job and I remove it from my code, Terraform stores the state somewhere else, and it can say, hey, you used to have this job, but now you don't want it anymore, I'm going to remove it. So we don't store a state with this package, but we'll get to that in a moment. Another really big one to think about is, as your project matures, and a lot of talks here have shown projects moving through maybe 3 stages of growth. So you have a very quick initial stage, you have a stage where you're trying to get more people involved, and then you have a stage where you're really trying to build your data products. You need to link to upstream and downstream tasks. So you have staging models, but you only want to run those staging models after new data comes in. DBT doesn't know when that data comes in. You're probably going to need another orchestrator on top of DBT to help with this. And if we jump to the other end of our lineage graph, you're probably going to have dashboards, and maybe you need to run extracts and refresh them. DBT also can't do that. Your orchestrator can do that as well. So you have no link to upstream, i.e. ingestion, or downstream tasks, so i.e. extracts for your Power BI, stuff like this, maybe even emails to some of your team, depending on how you work. There is a newcomer here, and this was mentioned yesterday. So this is DBTJobsC. So this is a repo from DBT Labs. It's relatively new. It does work. I have contributed. I had a chat with Benoit yesterday. He has big plans for this. So this allows you to do something very similar to the previous Python package that I mentioned, but this one is kind of stateful. So it gets rid of the previous disadvantage that we had. It's also maintained by DBT Labs, so you know it's going to work, and it comes with a bit of a guarantee of quality. So if anyone's thinking of taking this approach, absolutely look at this. It works the same way. You put a YAML file in your repo, and then it all gets rolled out via CI/CD. It's really nice. Right. Cool. So we've looked at some of the solutions. We defined the problem before that, but sometimes you have to ask yourself, what do you really want? And for anyone that's walked around the city, I've seen some Halloween stuff for the end of the month. We all know what's after Halloween in the shops. So yeah, I haven't seen anyone else with Santa this week, so maybe I'm a bit ahead of the curve, I wish. So what do we really want? And let's think about this. So we want the jobs to be configured in our repo. I don't want them to be configured in a Terraform repo that is separate. Why? Because I want my developers to be able to roll out relatively big changes in one repo, in one PR, in a joined up way that they have full control of. No dependencies on other teams, other release cycles. Someone needs to approve code freezes. Yeah, let's not do that. On top of this, I want those jobs to be defined in a language that my team is already familiar with. Terraform is not written in YAML, it's written in something else. So asking the team to learn that may be a bit complex. Both the Python packages we have shown today both use YAML, which is already used by DBT a lot. The second one, and this really depends on the maturity of your DBT project, we should have an orchestrator that is aware of both downstream and upstream tasks. So how does this match with the first one? So the first one talks about the job configuration. The second one talks about the job orchestration. So I want to, in the first one, the configuration, I want to say, hey, this job runs this command, and here is my select statement, here is my exclude statement. Maybe I want to do a source freshness beforehand. Maybe I want to run my tests. Maybe I want to run tags. But it doesn't say when this runs. I think an external orchestrator is the way to go about this once you reach a mature stage. Your external orchestrator can couple your DBT jobs with your non-DBT jobs, such as ingestion and updating extracts for your BI tool or sending emails. So, everyone wants a job. There are lots of different ways to do it. So if you have the same challenges, what things should you take away from this? So scheduling will work well, very well initially when you're at the start of your journey. It's pretty simple to get up and running. As your project scales, as it gets more complex in terms of data products, as it gets more complex in terms of the number of different teams you're dealing with, you will need to reevaluate this. Hopefully some of what we've presented earlier gives you some ideas on how you can do this. The last one, it is important that your job configuration has some separation from your orchestration. So you will have jobs that run every hour and just run a DBT command. Maybe because you know that you get data constantly streamed into your database. You don't need to wait for it. But as you grow, you're going to have different input data, different sources. They're not all going to be like this. So having an external orchestrator that runs jobs that you define yourself in YAML files, this will make a lot of difference. Cool. That's it from me. I hope I've given everyone a couple of ideas. Again, there's the QR code for anyone that wants links that was shown throughout. Also some contact details. We've run through that very quickly. Will we do Q&A? Yeah. Does anyone have questions?
For your
Yeah, so there's a large variety. So Airflow is probably the dominant player in the open source market. If you're in an Azure cloud, Azure Data Factory, even if you have Databricks has a workflows feature. You also have other specific orchestrators, Prefect, Mage, Dagster. The really nice thing is because you have the API in DBT Cloud, all of them work. There's no, you have to use this, it's not like that. The API gives open access to everything.
One other idea we're investigating is specifically for ingestion. A lot of tools like Fivetran can do the ingestion and then kick off the DBT models after.
Yeah. Dagster is also really good at this. Things are linked very well, and I know Airflow can be set up to do this as well. I think looking at the current features available, Airflow works the best. I think Dagster has made a lot of recent improvements as well. I think the reality is, if you're able to use both and you have access to both, there's no difference. They're both really mature products. Can you repeat the first part? Okay, so the question is how to decide on the granularity of models in a project. So maybe we should chat afterwards. There's a couple of different ways. So one is your data modeling. So are you Kimball? What is your granularity? Do you roll up? Are you aggregated? Maybe a different topic is how you split models across different projects. So maybe we can have a chat afterwards because I'll be staying around. Okay, okay. For the gentleman at the back, so Dagster being recommended.
We're using Dagster. We like it.
I feel like I'm in an advertisement now. Cool, I'm going to hang out. Also, lunch starts in 6 minutes, so I'm aware people want to run and jump the queue. Anyone that has questions, I'll be here. Cool, thank you.